Okay, so I'm going to download template for homework 3, and we're going to try knitting this and see what happens. Okay, and let me just... Okay, so it says you're supposed to go to baseballreference.com. I was trying to find a decent website with nice formed data, but something where you're going to have to do, where you can apply RVest. And so I apologize if you have no interest in baseball or have no idea what baseball is. It's a sport, it's a game, and we do things. Okay, so I asked you to write RVest code, but I don't want you to execute it whenever you render the our markdown file. Okay, and the reason for that is when you run RVest, you're going to be doing all of these, HTTP requests on the server, and I imagine this being kind of a smaller operation that's not going to be too much of a problem, but in general, it's always it's considered bad manners to repeatedly hit a server. Okay, and this is essentially, if you DD denial of service attack, basically just sends a ton of requests over and over again. And if you were to have written some poorly formed RVest code that repeatedly makes requests, you could get your IP address banned, and possibly they might trace it back to UCLA and think UCLA is up to no good or something. So yeah, I doubt that will happen, but it's just generally a good idea to minimize the requests that you send to a server. So if you're trying out a loop to see if your code works, always say like just for the first 2 or first 3 elements in the vector. Okay, and that way if your loop doesn't work, you've only hit the server 2 or 3 times, rather than in our case we're downloading things for 30 teams. And anyway, and when the grader renders your file, I don't want the grader's computer to be hitting all of these requests either. So we'll look at the code that you've written, but make sure you leave the eval equals false in there. Okay. So just so you can continue on with the data, I have created basically what, after you do the scraping of baseball reference and you do the cleanup, I've created the output file as baseball.csv. Okay, so you can kind of just make sure that what you have done matches what I have done. Okay, as kind of a guideline here. Okay, and so so this code should run. You're going to need to install the package reader, and this will load your the CSV file into the data frame baseball. Okay. And just looking at the structure of baseball, we see we've got 2,564 observations and all of these things. So again, when you run the data that you pull will just be ever so slightly different. Okay, it should still have the same number of observations and variables, but probably the playoffs column will be ever so slightly different, because there are teams currently still playing baseball, and so by the time you run it, maybe the results in the playoffs column will have changed. So for example, I think when I ran this, the Dodgers had not played their Game 5 against the Mets. They played last night and lost, crushing my hopes and dreams. So the current table here says tied in the National League Division Series, where if you look at it now, it will say lost in the National League Division Series. So anyway, that's what we have, and I ask you to use dplyr to do some summaries here. Okay, there's something called the Pythagorean win percentage if you're into sports analytics, you might be familiar with this, where based on how many points a team scores and how many points are scored against the team, you can kind of make a prediction for how many actual games the team will win. Okay, and then lastly, so today we're going to cover text expressions, regular expressions here, and you're going to apply regular expressions to the managers column to extract this data here where it says managers. C. Hale had a record of 79 wins and 83 losses, okay, while Kirk Gibson had 63 wins and 96 losses, okay. During this season, it was shared. There were two managers, okay. Kay Gibson oversaw 163 games, and A. Trammell oversaw 3 games. And I'm going to ask you to extract all of this information here, okay? Are there any questions on the homework assignment? So you guys have a week to do it. It'll be due next Friday. That should be more than enough time. Questions? We're all good? Everything makes sense? Okay. And we feel okay with dplyr, rvest? Yes, question?
Are there any ways to use rvest that don't use Magrider, or do they all just have to use it?
You don't have to use Magrider. But I think Magritte makes it easier. When you load library rvest, it loads Magritte in the background anyway. So you don't have to use it. So if you don't like using the pipe operators, you don't have to. But I think if you give it an honest look, I think you'll find that it does simplify the setup of your commands. Okay, so this is what it looks like, and so there's 30 teams, and how many basketball teams, how many hockey teams, and how many football teams? Do you guys know this in the major sports in the U.S.? 30 basketball teams, hockey also 30, and football, NFL 32. Okay, and okay, so anyway, MLS, I think there's, I think they just added a few teams, but I don't, Major League Soccer is not super popular in the US. Okay, so let's take a look at today's lecture. Okay, text processing and regular expressions. All right. Okay, so here I make use of the package stringr. There are already some built-in text processing functions in R, like gsub and grep and things like that. However, here, this is what we say. With string R, another package written by Hadley Wickham. We might as well call this introduction to Hadley Wickham's packages to R. He kind of created a unified format of these functions. Okay, so I think it makes it easier in terms of just doing string processing. Using this function library here. Okay, so again, just like everything else, install.packages. If you encounter trouble installing a certain package, okay, you can always choose install packages under tools here. Okay. All right, so my R has decided to bug out for a second, and you can choose a repository. It just, I'm sorry. This, it just says cran here. Okay, but you can specify, you know, the packages here. So you can do string R or things like that. And as well, where is it? Options? I forget where we choose our mirror here. Okay, so under options, you can choose packages, and you can choose your mirror. So sometimes the mirror that your computer has selected maybe has an outdated list or something just a little bit funny. So a lot of times these can be resolved just by going to the options, changing the package, the mirror that you use to install packages. Okay, so let's talk about string R. There are vignettes. These are like little help tutorials that you can look through. But we have a series of functions. Oh, I'm sorry. I don't know why there's pluses in front of all of these things. There should not be. We have string underscore detect, string locate, string extract, string match, string split, and string replace. Okay? And all of these, most of them have a underscore all suffix. So we get like string detect all, string match all, things like that that do different functions. Okay, so string detect will detect the presence or absence of a pattern in a string. So you say, you know, detect this string, this pattern in this string. Okay, and so where it says string, you can feed it, you know, a vector of character values, or you could just feed it one value. You can feed it, you know, a column from a data frame, and then it's going to go through, and if it detects whatever pattern that you give it, it's going to say true, or it's going to say false, okay, depending on what happens. The locate will return the first position of a pattern and return a matrix with start and end, okay. Extract will pull out the text corresponding to the first match. With match, you can specify groups that you want to pull out. Okay, so I'm going to demonstrate all of this. Split, you split your character strings into further pieces, and replace is kind of like a find and replace on your PC. Okay, so a lot of these things, you know, a common question is, well, why can't I just open up the file in Excel, you know, do find and replace, do all of these things, and search for things that way? And the answer is yes, you can do that. However, what you give up is, quote, portability and replicability. So if you were to give instructions for someone else, you would then have to kind of list out every single thing. You'd have to say, download this file. Okay, but before you work at it, you got to open it up in Excel and do the following find and replace operations. Okay, and you're going to have to write all of those out. With commands like this, essentially you're doing the same thing, but you're just writing it as a computer program. Okay, and you just say, well, run all these commands, and the computer will essentially do, you know, the find and the replace, or the extracting and things like that. And there are just certain things that regular expressions do that just make pulling out text a lot easier. Have any of you guys worked with regular expressions before? So like 3 of you, 4 of you? Okay. And the rest of you, this is fairly new, this stuff? Okay, so I feel okay that we're doing this. I would hate if everybody here is like, I already know regular expressions. Do you guys ever read the comic XKCD? Okay, XKCD will do regular expressions. There's a good comic here that just says, it says, whenever I learn a new skill, I can concoct elaborate fantasy scenarios where it lets me save the day. And it says, oh no, the killer must have followed her on vacation, but to find them, we'd have to look through some 200 megabytes of emails looking for something formatted like an address. It's hopeless. And then everybody stand back. I know regular expressions, and with regular expressions, you can identify things that look like an address in 200 megabytes of emails, okay? So, yay, hooray, the guy. This is Perl, but we're going to have R, okay? But, and stringer, so. But regular expressions, really, like, you can do really cool stuff. Okay, so here I am giving the text is just this character vector where we have the quick brown fox jumps over the lazy dog, okay? And so we're just saying detect in this character vector text anything that matches this pattern quick, okay? And so in this case, the pattern we have is an actual word, and we just say, do you see anything that matches this exact sequence of letters? And it says, yes, I identified it in the second thing right here, okay? And everywhere else, I have not found a match. Okay, all of these falses, it did not find a match in brown or things like this. Over here, we say, see if you can find the letter O in any of these things, okay? And it says, well, I didn't find it in the or quick, but I found one in brown, true. I found one in fox, also true. And then in over, here we go, and then dog. So we've got string detect there for O. And then, you know, for row, okay, R-O-W, it finds the match in the word brown. Okay, so far so good? Okay, and this is, so, you know, this is fine and all. This is just like you go into Word and you say, you know, you hit Control F and you type in the letters and it looks for this exact thing. So this is just like that, and you can apply it to any of these other things. But regular expressions get super powerful with these things called meta characters, okay? And these are all special characters that we can use that then give us the ability to match certain things. So if you ever want to actually do a literal match on one of these characters, so let's say you want to find a $sign, okay? You have to what we call escape the $sign. So you can't just say, you know, find $sign, or in this case, find the left square bracket. You can't do this because it's going to say, I don't know what you're talking about, okay? So you have to escape it, and you escape it using the backslash, okay? But the backslash itself is a special character, so you have to escape that too. So you always have to kind of do a double backslash and then the character that you want. So it looks funny when, you know, if you're not keeping track of your slashes and your escaped characters, you can confuse yourself, okay? But over here, so if you want to look for this literal character here, you have to double escape, double backslash, and this, and then it will say, oh, I have found that character in ABCD, you know, ABC bracket DEF, and it says true, okay? So if you want to look for any of these, you've got to double escape. But otherwise, we can use these in their, you know, powerful versions, okay? So again, we have to use the double escape here. Okay. So we have what we call anchors, and we can use these. So if you want to search something here, you can say, I want you to find the words that begin with K, all right? So you don't just look for K, you're going to say, look for K where it is at the beginning of a word boundary, okay? Or maybe you've got a bunch of lines of text and you want to make sure you want to find the lines that start with a certain thing, okay? So you've got serial numbers or something, and you want the serial numbers that start with the number 7, okay? Then you would put this anchor here that says /A to say at the beginning of the string, find the number 7. So you'd be /A7, okay? Otherwise, it'll, you know, match every single 7 that it finds everywhere, okay? So here, you know, so we've got match the beginning, or, you know, find all the numbers that end with the number 0, or, you know, find all the words that, words that end with this. You can put this at the end of a word, or this is called a not a word boundary, and I'll I'll show you that. Okay, so basically this is just, we don't want it to be at the edge of a word. All right, so here it says so notice our text is now just one string that says the quick brown fox jumps over the lazy dog. And here we're using the command string replace, which will look at the text, search for this pattern, and if it finds this pattern, it's going to replace it with the dash. So because I've put this little thing, what does this stand for? This stands for the text has to begin with the word the. Okay? And so it goes here, and then it says, oh, I did find a match at the beginning of the string for the with a at the beginning, and so I'm going to replace that with the dash. Over here it says replace instances where the string begins with the word dog. Okay, begins with DOG. It says I looked at the beginning, it doesn't match the beginning of dog, so over here this doesn't get replaced because this does not match this, because this is not at the beginning of the string. All right, is the distinction here okay? All right, and the same type of thing dealing with the end. Okay, so if we put end at this word the does not match here because it's not at the end of the string. However, dog with the end matches because the word dog, I should highlight over here, matches the end of the string here, and so it gets replaced. Okay, so this again is another way of showing the beginning of the string. Okay, so notice I have to do the double \A. Okay, and so this is strings that start with the word the. Okay, and again, this doesn't work when I have starts with quick, or but this works. Ends with dog. Yes?
Does it only, when you specify that you only want it from the beginning of the sentence, does it only take the first one? Like, say you have 4 dogs in one sentence, does it only take the first one and leave the other 3?
So, okay, so if you're using this, one of these anchors, okay, then it has to be at the very beginning of the string, okay? So it'll only look for dog if the string starts with the word dog, okay? What you're asking for is string match or string extract, and will it find just the first or will it find all of them? You have 2 options. You have string extract, which will find the first, and string extract all, which will find all of them. Okay, so we'll do some demos, okay, in a second. So here I'm using the word boundary character //b. Okay, so this says, find matches where you have the entire word jump, okay, and you have the beginning and end of a word. Okay, so we've got word boundaries. So it finds, the quick brown fox jumps, it replaces that. Okay, but notice if I change it from jumps to just jump, okay, we no longer have a match here because this part matches, //b jump matches this part, okay, but it doesn't end with a word boundary, so we no longer have a match for the word boundary there. All right. However, if I do capital B for not a word boundary, so this means find the letters UMP, and it must be inside the word, and it can't be at the edges of a word, okay? It can't be at the edges of a word, then replace it, and so we see it replaces UMP here. However, and if I put in a J here, this says make sure if you match it, it's not at the edge of a word, okay? So it's not a word that starts with jump, J, or ends with P, and so it no longer matches this word. Okay, so I don't know if this is incredibly painful to watch, but we've got, so you have all of these commands to say, I want it in the middle of the word, or, at the start of the field, or at the start of a word, okay? All right, we also have you can specify character classes, okay? So So we showed, you can match letters, okay? The, quick, all of these things. You can also say, I want you to match white space, okay? So this includes both breaking and non-breaking spaces, or, this is anything that's not white space. Match a digit, meaning 0 through 9, anything that's not a digit, okay? And then match what is considered word. Why did this happen again? Okay, so words are capital letters A through Z, lowercase letters A through Z, and the digits 0 through 9 or an underscore. So these, this captures all of these letters here. You can also specify ranges. So the dot is kind of just like an any character. So this is like the wild card. Match any character. You can say match any letter A, B, or C. Okay? Match any, if you put the little caret here, match any letter other than A, B, or C. Okay, or not any letter, just any character that's not A, B, or C. This is match lowercase letters from A through Q, so you can specify a range, or capital letters or digits, and you can specify ranges for all of these things, okay? So I'm just introducing, I know this is a lot, okay? We'll do some demos, and I think, well, I hope it will convince you that regular expressions are pretty neat, okay? So, and then you can then quantify. You put a star, a plus, a question mark, okay? These say, I want you to match the letter A, and I want you to match, multiple of them, or, digits. Match digits and match exactly 3 of them, or match 3 or more, or match anywhere from 3, 4, or 5. Okay, so you can specify how many you want to match. So something, when you're trying to match a phone number, you can say take a digit, and I want you to match, if we're formatting American phone numbers, you've got, match the parentheses, match 3 digits, and then the close parentheses for the area code, or something like that. We have, there's something called greedy matching and ungreedy matching. So notice this text here, okay? And so what this says is match this pattern, okay? Find a piece of text that starts with, bracket div and ends with bracket slash div, okay? Okay, or the tag, the closing tag for div. And then it says dot star, which says take everything in between, okay? So dot is the wildcard character, right? So any character, and star means any number of those, okay? So, whatever characters you find in between div and slash div, I want you to match all of those things, okay? So this is what we call greedy matching. And so it will say, okay, it's going along here, and it says, I found the beginning, the opening div tag, okay? And it goes along, and it says, oh, here's a closing div tag. That's good. Oh, here's another closing div tag, okay? I'm going to try to maximize and be greedy in terms of matching everything. And so it takes the opening div tag, and then it takes the second closing div tag. You throw in a question mark, and that says, don't be so greedy when you match. And then so it takes the opening, and then it takes the first closing div tag without getting the second one here. All right. Okay. And so I'm just throwing all of these kind of at you in the beginning, and then we'll demo some of this stuff. Okay. So and then we've got groups. So here you can match this string here, okay? So it says match A, B, C, D, okay? But then what we want to capture, we're essentially saying once you find this string here, the only thing that I actually want to store is the stuff inside the parentheses, BC, okay? Or you say, the stuff I don't want to store is this stuff. And here you can specify multiple groups to store. I want you to store ABC and GHI, drop the DEF, okay? So here I've got A, B, C, D, E, F, G, H, I, J. And the pattern is going to be A, and then we're putting BC inside the parentheses to indicate this is the group that we want to match, okay? So string extract just takes the entire pattern and pulls it out of the text. That's string extract. However, string match tells you the matching pattern. It finds A, B, C, D, and then it extracts the part that you want, the BC. Okay, so you get a matrix that says this is the part that I found, and this is the part that you told me you want to keep. Yes, question?
So if there's like, say like A, like D, E, D, would that, or sorry, A, E, F, D, would then put E, F, or does it have that with BC?
Yeah, because I put BC, it's got to match BC. Okay, if you just want find, here's the letter A, here's the letter D, okay, and then I want you to get whatever gets in between A and D, then we would not put the literal characters BC. We would put in like either /W for any character here, or dot star to say anything, or if you just want letters, then you can specify A through Z, things like that. Okay, so in this case it says basically we're saying you got to find this exact thing, right? It has to start with A, it's got to start with D, and the two middle characters must be BC. But I could put wildcard characters in here, and we'll say it's got to start with A, it's got to end with D, and then whatever's in between A and D, I want those things, okay? So we can try out a bunch of these things, okay? And then so here, it's got to start with ABC, it's got to end with GHI, and it's got to have DEF. So it's basically got to have this exact string. And then the two pieces that I want to save are the ones that are in the parentheses. So if I use string match, it pulls them out. And then I can reference those columns here. All right, so let's take a look here, okay? So here I've got text. It says Apple, okay? And then I've got a phone number here where somebody put spaces in between the things, right? So you imagine like somebody sends you an email. Can you send me your phone number? How do you write your phone number, right? People might write it with spaces in between. Somebody else might respond and put dashes, okay? And then and here, this is, so notice I've got 1, 2, 3, 4 things in my vector, okay? And here for this last one, this person put 2 phone numbers and said this one's work and this one's home, and they use dashes over here and they use dots over here, okay? So what am I doing? I'm gonna extract the phone pattern, okay? And so if you know about area codes cannot start with a 0 or 1, right? So the first digit must be between 2 through 9, and then the next 2 digits can be between 0 and 9, and how many digits? I want 2 of those. Okay, so this matches, the first digit must be between 2 and 9, the next digit must be between 0 and 9, and I want 2 next digits. And then I put the parentheses around here to indicate this is the first capture group that I'm interested in. Is that okay? And then it says match on a dash, a space, or I think this is the wild card actually, or is it the literal dot? Oh, I think I need to have a / dot here. Okay. And then it says the next capture group is the digits 0 through 9, and I need 3 of those. Okay. And technically we could actually do 2 through 9 because we could actually have this exact same match pattern here. Okay, and this is another capture group. And then lastly, the last 4 digits are 0 through 9, and I'm going to have 4. And this is the final capture group. So when we apply this pattern to the text here, it says, I don't have anything to extract from Apple. When I look at these numbers, I got what you asked for. When I find these numbers, I got what you asked for. And then when I look here, it only pulls out the first match. Okay, it finds the first match and it says, I got it, and it's done. Okay, let's say if you want the second one as well, then you've got to do string extract all. Okay, so we're going to do the same exact thing, and if this time I'm using string extract all. In string extract all, string extract will take a vector that has 4 things in it, and it will return a vector with 4 things in it. Okay, string extract all will take a vector of 4 things and return a list of 4 things. Okay, so the first one says I didn't find anything. The second one says I found this match. The third one says I found this match. And string extract all will say, for the fourth one, I found 2 matches. I found this match and I found this match. Okay, so when you use string extract all on a vector of 4 inputs, you get a list output with four things in your list, and each list contains all of the matches that it found in that input piece. It's like somebody's stomping on the roof or something here. Okay, so is this all right? Okay, and then we can use string match, where it finds the remember, so when we did string extract, it found these matching things. It took a input of 4 and an output 4. String match will take the input of 4 and return a matrix with 4 rows, and it returns the matching pattern as well as the capture groups that you specified. Okay, now again, because that last one had 2 things, for string match, it just takes the first one that it matches. But if you want to match all, you can do string match all, and it will return a list, and each list will be a matrix with the number of things. So it says, so the first one it found nothing. Okay, the next one it finds this, and it returns the 3 capture groups that we have specified. And over here it finds the 3 capture groups, and here it found 2 matches, and it specifies the 3 capture groups. Okay, are we okay? All right, so you have what didn't I? Let me check here. I must not have. Give me a second. I think I have to re-render this. I have some the last page in here. I have some links, okay, that are very useful. There's a regex regular expression cheat sheet, and then you've got this site that allows you to test regular expressions. Okay, so here we're going to let's say I want to find words that start with M and end with S. What should I write here? So here I want to find the word matches, mistakes, and I think that's it. Okay. So how would I say I want to find a word that starts with M and ends with S? So I would have to do. So here I don't need to do the double escape, so I'll just do word boundary. Okay. We're going to find words that start with M. Okay. And then we're going to take any letter, really. Okay. And we're going to take as many as we want. Okay. And it has to end with S. And that forms the end of the word boundary. Okay. Is that okay? So starts with M, ends with S. So I have the word boundary, M, word boundary, okay, S. So it starts with M, ends with S, And then in between, I'm going to take any character here, so /w, any character that might appear in a word, and I'm going to put the star to say I'm happy with any amount that you might give me. Okay, and so here I can modify the text, and I can say I can put underscore here, and it'll be fine. But if I put in the pound sign here, it no longer matches. Okay. And if I write another word here, mats will work, but then if it ends with a G, it no longer matches. Okay. All right. What if I want to extract so let's take these web addresses, okay? But the part I only want to keep is going to be the stuff that comes after http://. How do I specify that? Okay, so I want to find things that match http://, okay? And then I'm going to take basically anything that comes after that as well. Okay, but the capture group that I want is just the stuff that comes after it. Okay, so this entire thing matches, but then when I hover over it, we can see that the group, it says group that matched, does not include the http://. Okay, and over here, it has the entire thing, but it doesn't match it. The group that we captured is just the beginning part. Okay. What if I just want to capture the top level domain? So I want foo.co.uk without the slash. Okay. Then I would just throw on the slash here. Okay. And it says, okay, well I found something that goes ///, and then here, so now we see that the group that matched is regularexpression.com, and over here foo.co.uk. All right. Do we have time? Let's see if we can go to IMDb, and we'll go to the top 200. Why do I always have trouble finding the top rated movies? Okay, so we're gonna go here, and so notice this list has the name of a title along with the year in parentheses here. Okay, so I'm going to run rvest here. Okay, and then we're going to have page read underscore HTML. Okay, and then so with our selector gadget, what I want to pull out is I'm going to pull out this column here. Okay, so we got title underscore column. So we're going to do titles will be page HTML nodes colon this. Okay, so let's take a look at what titles has. So it has all of this stuff, okay? And somehow we want to, so we've got everything in here. So let's just look at one of these okay. Maybe this is too much text. But we can, I think I can do a match where essentially I can't, let me just cat. I can't get the thing, so I think I have to I have to do selector gadget and just pull out the text. This is, okay, this is not what I wanted. I wanted the the entire thing here. Let's try this. Sorry. Okay, so we're essentially looking for, we want to capture something that is in this span that says secondary info 1957 slash span here, okay? So we're going to take titles and we're going to put it into string match, okay? And what we're going to do is the pattern that we want to match is going to be basically this, except, oh, and so to indicate not to look at the quotation mark, you've got to escape it. And here we want the literal open and closing parentheses. And so let's, I'm going to just run this. And so this will only find where it matches 2008. Shoot. Of course, my live live demo is not going to work here. Oh, and I've run out of time. Okay, so sorry, I guess you only need a single slash to escape the quotation mark. Okay, so here it has found a match where it has 2008 here. So what I want to do is I now want to replace 2008 with digits. Okay, so I'm going to say starting with 0 through 9, and I want 4 of them. Okay, and so when I do this, it now it matches all of these things that it has found. Okay, and so now the capture group that I want is just the digits. So I can just put parentheses around those digits, and it will just extract out the year. It'll create a column with just the year of digits that I want. So here you can kind of feed it just a bunch of text, and you can say, I just want the 4-digit number that you see in between parentheses, and you can do it like so. All right, and so now that we have string match, we can then take the take these returned results and just look at the second column. You know, drop all of the NAs. And I believe there's just going to be 250, okay, for our 250 top movies. So with regular expressions, you can do just some really powerful text modification and extraction of information that might otherwise be painful to do. Okay, we'll end there. We'll see you guys